You are the proud owner of 50 centimeters of string.
Yeah. Yes.
I know. It's a great day. I promise it'll improve. Because,
Half a meter.
yeah, this is like half a meter of string, man.
Straight up.
That's so much. No, that's not that much string. That's like this much string. Bummer. I thought we were rich for a second there. I was going to sell it. Anyway, I'm now supposed to, with my newfound 50 centimeters of string, enclose the biggest rectangle I can. Right? So,
Biggest meaning area?
yeah, biggest meaning area. So, what should I do with my string at first?
Set it on a table.
Good, Rick. Enclose some rectangle, and then talk about that rectangle. So to make things easy, I'm going to start my string at a corner. I'm going to go out a ways, and then I'm going to go down a ways, and then I come back in a ways, and then I'm going to go up a ways. Right? So I have here my piece of string encapsulating some rectangle.
How are your ends attached?
They're not attached.
They're not. They're just set next to each other. Don't be ridiculous. We're not building a pen or something. There's only 50 centimeters of string. Best you could hope to fence with this is a small bug that's not very good at climbing. So, yeah, this is actually a really silly example. I wish they had given you like 500 feet of fence.
Yeah.
Right? That would be maybe a better use of this.
Yeah, seriously, why did they give you 50 centimeters
I don't know.
of string to make a rectangle?
Okay, so at any rate, this would apply to fencing. So what I would like to know is what's the biggest area I can enclose here? So the first thing I should do is try to figure out how much area I've enclosed with this one, right?
Sure. Oh.
So I went over a ways and then down a ways, right? And then I went back that same ways and up a ways. Oh wait, that was the same ways I went down earlier, right? So I think I've got, how many variables here? Two, right? The over and the down. So I'm going to call those V and D.
Okay.
Over, ver, and down. Don't use O as a variable. That would be silly. Bailey goes, why? And then he goes, never mind. Never mind. So, you like to use numbers. It's very... Call this side 3. It could be any number. Yeah, don't do that. Okay, so more math, less screwing around. I'm trying. What do I know about V and D?
Well, that they make that V, the 2V plus 2D equals 50.
Nice. They're half of your string.
Yeah.
Right? Together, V and D are half the string.
Right.
Or
2V plus 2D.
2V plus 2D is 50.
Right.
Right? But either way, you get some equation that boils down to V plus D is 25.
Yeah. Centimeters. Yeah.
Are you with me on this?
Agreed.
Okay. Next thing. What the heck was I doing?
You're trying to find area.
I'm trying to find the area.
Largest area.
What's the area of this one?
Depends on what V and D are.
V and D?
Yeah, it depends on what V and D are, so it's V times D. Okay, so I know two things. I know that V plus D is 25, and I know that the area is V times D.
So 25 divided by 12. No. Well, I figured that V would at least be 12.5, but D has to be smaller than that.
Yeah, I'm not sure.
No, because it's rectangle. Can't you make a square?
I could make a square.
Yeah.
Oh, you can? Alright, then let's do that.
But I don't know that's the biggest one.
Oh.
Right, that's just some one of these. Like, I could make a square, but I could also make this rectangle, which is not a square.
Right, that's true.
So,
Rectangle's more like a 15.
where's the parabola?
Where's the parabola?
It's,
Solve for.
I don't know, that's why I asked this question.
Rectangle, what are you doing?
So, I have two variables right here. This is the thing I want to make the biggest, right?
Yeah.
So, if I had a picture of this, I could maybe find the spot where it was biggest. But I can't make a picture of this because it has two things in it. I don't know how to graph functions of two variables yet. But there's one more relationship here, this one. So can you use the v plus d is 25 to get rid of one of these two?
Yeah.
Yeah, you
You
can
can
set
solve
v
for v or
equals
d
1.
and then substitute it into the area equation.
You guys see that?
That's sick.
So if I solve for one of these, like say I'll solve for d, I guess. So d is 25 minus v, right?
Yeah.
Take that thing and stuff it in here for d. You'll get area is what?
V times 25 minus
So I'm with you on multiplying this out,
v. Yeah.
except that I wanted to point out something cool, which is what happens when v is 0 here?
Everything's 0.
You get 0 area, right?
Mhm.
What does that look like in rectangle with string land?
It looks like a string.
2D. There is no 1D. You comfortable with that? You burn it, incinerate it.
This is a little more than
Just a line.
more string than I'm supposed to have, but
Oh yeah, because X is 0.
I think it looks like this, right?
Yeah.
Said rectangle has, that was v is 0, right?
Mhm.
So that would be this one. What's this one coming from?
Y is X is 25.
Yeah, that's when d is 0 when v is 25, right? Because it's out and then back.
25.
You guys see that?
Yeah.
Both of those are 0 areas, right?
Yeah.
Mhm.
So what's the best you can do?
Oh.
Halfway between those? Yeah.
Probably halfway between those. How do you know it's actually halfway between those? Because this thing's a parabola, right? So the vertex is halfway between the two
Right.
x-intercepts.
Yeah.
Because parabolas are symmetrical, right? You guys remember that?
Wow.
So the maximum,
Yeah, that's interesting.
okay, so the max or a minimum, I'm not sure which one it is because it's a vertex, right? You guys see that?
So it could either be naked up here.
It could be like this or like that,
Okay.
right? So the max or the min is at v is what? What's halfway between 25 and 0?
12.5.
She is victorious 12.5.
Intuition.
Yeah, intuition's good.
Yeah.
On these, it's really good, right? Because you know in your heart that the biggest thing, the biggest rectangle you can make with a set piece of string is going to be a square.
Yeah.
Okay, so how do I know it's a max, not a min?
Because the parabola opens downwards.
Yeah, the parabola, if you kind of think about your a term here, right? The parabola's got a negative a, so it opens down, so its vertex is a maximum. But you should think about that.
That's super sick.
You guys cool with that? You want another example? Something like this? Let me just sketch one out briefly. If you had, say, 50 feet of fence, right?
Mhm.
And you wanted to make 2 pens like this.
One is smaller than
Like
the other.
separate pens. Possibly one is smaller than the other.
Okay.
Make them squares just for kicks.
Okay.
Right, like you want to make 2 square pens in your yard. One's going to hold your rabbit and the other one's going to hold your garden.
Okay.
Right? If you want to enclose as much area as possible, what does your intuition say you should do?
Cut 12.5 in half.
Yeah, just make them the same size, right?
But that's wrong.
Probably measure your yard.
That's actually the minimum you can make.
That's interesting.
You guys see that? If you make these 2 squares the same size, that's actually the smallest area you can enclose. The biggest area you can enclose is by not making this one and using all your fence to make 1 pen. Right? So, little tiny pen for rabbit, nice big pen for
Good.
well, so you should think about that checking. Is this actually a max or a min? Bears some thinking. Cool?
Cool.
But you would do this problem exactly the same way we just did that one. Right? You'd make some equation for the area, you'd make some equation for the amount of fence you use, shove one into the other, look at the parabola.
You really want to put one inside the other.
But
Yes.
one pen inside the other.
Oh, yeah, probably the best way to do it would be to
Take a
count
corner,
2 pens in each other. Yeah.
take a corner off the big one.
or just the circumference.
Just like
of it, you could just,
overlap
like,
them, right?
Yeah.
And be like, it's 2 pens, I promise. Yeah, you could do better by like sharing a side. That would create some interesting stuff. You can do better by building it with one side against a building. Is anybody enough of a ranch kid to know if you put a pen against a building, what you should use for the sides?
Besides the building.
Yeah, so when I ask this question at Montana State, there's always at least one kid in the room who goes, 2 to 1.
Mm.
You got an existing fence, it's always 2 to 1. And they're right. That's the mathematically best thing you can do. Like if you have an object, like maybe around here the object would be something like a big ass cliff. Right? Like if you had a chunk of Table Mountain, right? You don't really need to fence the cows out from climbing the cliff. They're not big into that kind of thing. Right? And if you want to make a pen down there, you do 1 piece this way, 2 pieces that way, and 1 piece this way. That's the best you can do. But you would do that this exact same way, right? You would make some little thing and find the parabola in there. Cool?
That's really funny. Building a fence against a cliff, open to